In this video, we will introduce the concept of imaginary numbers and complex numbers. We'll begin the introduction by solving the equation x squared plus 9 equals 0. While we do have the option to use the quadratic formula, I think it'll be simpler to use the square root property. The first step in solving this will then be to subtract 9 from both sides of the equation to isolate the x squared. And in doing so, we obtain the equation x squared equals negative 9. Now, to solve this equation using the principle of square roots, or the square root property, we know that if x squared equals a number, that x will equal either the positive or negative square root of that number. So in this situation, either x equals the square root of negative 9, or x equals the negative square root of negative 9. These values, the square root of negative 9 and the negative square root of negative 9, are not real numbers. There is no real number that I could square to obtain negative 9. So I could have actually stopped at the equation, x squared equals negative 9, and simply stated, there is no real solution. Now we need to stress the fact that we're saying there's no real solution, meaning there is no real number. There is no number on a number line that will be a solution for this equation. That is very different than saying there is no solution at all. The fact is, there are two solutions, and we have found them, the square root of negative 9 and the negative square root of negative 9. These are simply numbers that don't fit on the number line. These two numbers, the square root of negative 9 and the negative square root of negative 9, are what we call imaginary numbers. When we first start learning arithmetic and we first start learning about algebra, we restrict ourselves to the real numbers, so the numbers that we can put on the number line. And this diagram gives us all the categories and subcategories of the real numbers. The real numbers split into those that are irrational and those that are rational, those that cannot or can be written as a fraction. And within the rational number category, we have subcategories of integers, whole numbers, and natural numbers. But all of those are numbers that can be found on the number line, and every number that can be found on the number line fits into one of these categories, or maybe more than one of these categories. The fact is, there are numbers that don't exist on the number line but are still numbers, and that the real numbers are actually a small part of a larger system. Returning back to what we had previously been working on, we came up with the square root of negative 9, and we recognize that the square root of negative 9 is not a real number, meaning there is no real number that we can square and have the result of negative 9. The square root of negative 9 is what we do call imaginary numbers, and these imaginary numbers are also part of a larger system called complex numbers. The foundation or basis of the imaginary numbers is the number I. I is the square root of negative 1. It is the unique number for which itself squared is equal to negative 1. I is called the imaginary unit. And by working with I and working with the square root of negative 1, we are able to simplify things like the square root of negative 9 to actually put them into a more symbolic form. If we want to simplify a square root involving a negative number, the way we do it is this. In general, if we have the square root of negative a, where a is some positive number, then we separate the negative 1 factor from the a, and we split that square root of negative a into the square root of negative 1 times the square root of a. The square root of negative 1 will simplify down to I, because that is the definition of I. If we can simplify the square root of a to be something a little bit cleaner, we will do that. So for example, working with the square root of negative 9 we had from the beginning of this video, the square root of negative 9 would separate into the square root of negative 1 times the square root of 9. So we're separating out the negative 1 from the positive number. The square root of negative 1 will again simplify to I, and the square root of 9 simplifies to 3. So the square root of negative 9 is really the same thing as I times 3. But like we would do with any variable, we wouldn't write I times 3. It would be more standard to write that as 3i. We do need to be very careful here. I is not a variable. A variable is a letter representing an unknown value, and I is not an unknown value. I is a very specific value. It is the square root of negative 1. Because of this fact, you will rarely, if ever, see I used as a variable in any situation. We do this with other letters as well. Pi, for example. We're all familiar with pi as being the ratio of the circumference to the diameter of a circle, and it has a very specific value. Pi is about 3.14159 and so on. So even though pi is a letter, It is not a variable, it has a very specific meaning. And the same is true about I. I will always be equal to the square root of -1, but it becomes simpler in the work we do to write it as the letter than to use any other way to represent its value. So an imaginary number is any number that can be written in the form of a real number times I, again where I is the square root of -1. So if it can be written in the form of b times I, where b is a real number and b is not 0, such as 5i, -2/3 I, the square root of -25, or the square root of -20, those are all imaginary numbers. They have a value, they have a meaning, they simply do not exist on the number line. Now, imaginary numbers and real numbers are kind of counterparts. Together, they live sort of side by side, and they help form a system called the complex numbers. Complex numbers are numbers that are written as the sum of a real number and an imaginary number. But it is important to note that the set of complex numbers is more than just the gathering of all the real numbers and imaginary numbers. It's actually including every real and imaginary number that could possibly be added or subtracted. So to give you a visual of this, the system of complex numbers is the larger system that we are actually working in. The complex numbers, again, are all the real plus imaginary numbers. So that entire diagram we had earlier, where we are just showing the real numbers, represent just this smaller right-hand box. So we have the real numbers down there. Separately, we have the imaginary numbers, the pure imaginary numbers to the left of that. And then as we start to add and subtract values from each of these two boxes, that gives us our larger complex number system. More often than not, for the algebra that we do, we tend to exist in this real number category. But the further you go with mathematics, the more important you'll see that these imaginary numbers become, and you'll start to see uses for them and ways that they can get applied to give you more information than just staying within the real number system would allow us to do.